So here we're just going to practice our differential equations. Again, the key is to separate and integrate. Okay, so we're going to separate our variables. Okay, so that's our first step. And then secondly, we're going to integrate both sides of the equation. So here we've got our y's. I'm going to separate our y's to the left-hand side here. So I'm going to divide both sides by y. So again, we have to be able to algebraically move these. So it has to be times and divide. And we're going to put the dx's on and the x and the dx onto the right-hand side. Okay, be careful with your algebra. Okay, moving that around. And then once we've separated, we're going to integrate both sides. This side becomes log y. This side becomes x plus 1. We're going to use power rule. So we're going to do it like that. Okay, and plus c. Okay, we could do this as x squared plus x, and then our plus c involves another extra plus 1 in there. Okay, so that we could have a different plus c depending on if you integrate that as a horizontal compression of left 1 or integrate that separately as x and 1. So solving for this, I'm going to end up with y equals e x plus 1 squared and then a plus c. You could leave it like that. However, if you recognize that that plus c can be rearranged algebraically, we end up with y equals, I'm going to change that to k times e to the x plus 1 squared. And that k is really just how the plus c shows up. Now, if we had done that, I'm going to show a slightly alternate solution here. So I'm just going to show this as an alternate solution. As if we had solved this, we get log y is equal to x squared plus x plus c. Okay, this is going to look slightly different, but it is the same solution. We get y equals e to the x squared plus x plus c. Now, there is a difference in the plus c on the left and plus c in blue. That the plus c in blue actually includes the extra plus 1 you would get if you expanded out that bracket. But this solution is just as valid. So we're going to change that plus c into k times e to the x squared plus x. The difference is that the k I solved for here and the k I've solved for here, they're not equivalent, they're different. Okay, just to differentiate them, I'm maybe going to put a little 1 there to show that plus c and the k are different from the ones in the original solution. So same thing here, we're going to identify the y's and group the y's. We're going to put the dx with the x. That constant can go on either side. I'm going to end up with y. That becomes times on the left side. Again, watch your algebra when you're doing this. On the right-hand side, the x stays in the denominator, so I get negative dx over x. Integrating both sides, I get y squared is equal to negative log x plus c. That plus c, again, we could solve for if we're given some condition. In this case, we're not, so we're going to solve for y. We get y is equal to, I'm going to rewrite this as c, So we forgot to divide by 2 here, so y squared over y squared over 2. So then solving for y, we get y squared is equal to 2c minus 2 log x. Okay, so y equals plus minus the square root of 2c minus 2 log x. Okay, we can leave it like that, but since that square will get rid of the absolute value, we're just going to put that in. So y equals plus minus 2c. Again, you could, if you want, you can change that 2c into the c because it is really just a constant, and then minus x squared, and that allows us to drop that absolute value. So that absolute value is there because we need to be able to accommodate negative and positive x's. So once we square that x, that no longer becomes an issue. For c, we've been given an initial condition, so we're going to be able to solve for the plus c. Okay, so we're going to be able to solve for the plus c here. But again, the same thing, we want to separate the variables. So x's with x's, y's with y's. So I get dy I'm going to divide by y on the left side. That's going to be equal to 1 plus root x all over root x dx. Okay, and then integrating this. Now, the integral of this is tough because on the right-hand side, on the left-hand side, we get the log. But on the right-hand side, we're going to have to do a substitution. So I'm going to let my u equal, well, my du has to accommodate the derivative must accommodate the outside. So here, if I let the inside be 1 plus root x, the derivative will give me a root x in the denominator. So this is what I'm going to do. So I'm going to let u be 1 plus root x, and then the derivative is going to be 1 over 2 root x times dx. Now we only have, I'm just going to circle this here, we only have a x dx. I only want that part, so I'm going to rearrange this to 2 du is equal to dx over root x. Okay, so then now I have the substitution I want. So on the right-hand side, this becomes u times 2 du, so I'm going to put the 2 on the outside here like that. Now I can integrate the right-hand side, so I get log y is equal to, that's going to be u squared over 2, so it's just going to be u squared, and then I need my plus c. Okay, before I plug in my x and y, I need to make sure I do my substitution. Back for x, so I get 1 plus root x squared plus c. Okay, and again, just highlighting this as 1 plus root x is my u that I was using here. Okay, so at this point, I'm going to actually solve for my plus c. So, well, actually, because this is exponential, so we'll put it into exponential form first. So putting it into exponential form, we get y equals e to the 1 plus root x squared plus c. Again, that plus c will end up as a constant coefficient. So I'm going to solve for it as a k value out front. Okay, so that plus c becomes a k when I rearrange that using some exponent properties. Okay, so at this point, I'm going to plug in my y and x. So 1 is y is equal to k e to the 1 plus square root 4 is my x squared. Just going to color code that. That 4 comes from my x value. And then I can solve for my k. So I get 1 equals k e to the 1 plus square root 4 is 2. So this becomes 3 squared, which is 9. The k is equal to 1 over e to the power 9. So the solution of this differential equation that passes through the point 4, 1 is y equals 1 over e to the 9 times e to the 1 plus square root x all squared. So there is the solution to my differential equation, and this solution passes through that specific point 4 and 1.